Okay, today we are going to talk more about non-proportional relationships. This should just be a refresher since we talked about non-proportional relationships last week. So right now we are working on handout 5. So you should be following along with your notes. At the top it says FitLife Gym charges customers for each month of membership as shown in the table. We're going to use this information to answer these two questions. The first one wants us to sketch a graph. So I'm going to take these points from the table and put them into the graph. I know at the top these are my x's and at the bottom these are my y's. So I'm going to go over here to my graph. This is where x equals 0. So I'm going to go 0, 10. Here's my first point. 130, 250, and 370. And then I'm going to draw my line to connect those. So here's the line for that relationship. And then it asks, is this proportional? Well, we know in order for a relationship to be proportional, it has to go through the origin. And my line does not go through the origin. It does not start at 0, 0. So I'm going to write no. This line starts at 0, 10. So it is not a proportional relationship. We know also that if a relationship is non-proportional, the ratio will not be constant like it is when we have proportional relationships. Remember, proportional relationships, there's a constant y over x, and we don't have that anymore now that we're talking about non-proportional. All right, down here in this box on the left, we're talking about tables. So we know with tables, the ratio of y over x is not constant anymore. And we no longer have the point 0, 0. We do not have the origin anymore. Instead, we're going to have the point 0 and some other number. So you can see right here in this table, I have this point 0, 9. That is our b now, our y-intercept. We know if we're looking at a graph, our line is not going to pass through the origin anymore. On this example, here's the origin. Our line doesn't go through it. Instead, it's going to cross over the y-axis at a different point, so either above or below the origin, and that new point is called the y-intercept. Again, this should all be review because we talked about this last week. Down here at the bottom of the page, number 1, we're going to complete the graph that the table shows us. So starting off, we have this example that's about terrific trampolines. We always know in our graphs, x's, or in our tables, x's are on the left, y's are on the right. So I'm going to drop those points into my table. The first one I have is 0, 6. Notice, since this is a 0, we know the number next to it is going to be our b. So if I were to write my equation, I would have a b at the end, or a 6 at the end of my equation for b. So we start at 0, 6, and we go over to 1, 8, 2, 10, and 3, 12, and connect the dots. There's my line for terrific trampolines. Over here, there's not a situation. It's just x and y values. Notice over here we have 4 quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So this one does go over into the negatives if we need them. So I'm going to start off with a point 0, 1. That's going to be right here. Then I have 1, 4, 2, 7, and 3, 10. And I'm going to connect my line there. And although it doesn't tell us, we don't have the points in our table, this line does continue going this direction. Lines go in both directions. So even though I don't have the points explicitly in this table, lines keep going, okay? All right, flip it over, down here at the bottom. How can we determine the rate of change? We already know this. We learned it last week. Anytime we're finding the rate of change, m, we're always going to do change in y over change in x. Remember, we are not just doing y over x anymore. We're looking at how they're changing. That's the most important part. Okay. All right, on to the next page. If you flip it over to the back, we've got an example on the top. And this example is talking about Pizza Palace. So it says, at Pizza Palace, Rashid orders a pizza that cost $8 plus $2 per topping. I know anytime I see this word per, that's going to be my M. Complete each representation to show the relationship between the number of toppings, X, and the cost of the pizza, Y. So I know toppings are my X's, cost is my Y. So I'm going to fill out the table, then I'm going to put those points in the graph, and then I'll write my equation. I already know, I'm actually going to start with the equation first. Since I know that 2 is my M, I know Y equals 2X, that means the $8 has to be the B, since that's my starting charge. I can't order a pizza that costs less than $8. So he goes at, plus 8. All right, now I'm going to go over to my table. We don't always use this process thing. I'm going to show you how it works. So we're pretty much just going to take this equation, and whatever X value we have is going to go in right there for that X, if that makes sense. So starting off, I'm going to do 2 times 0. That's just 0, plus 8 gives me 8. So I know on my table, I'm going to have on my graph, I'm going to have the point 0, 8. Now I'm going to do that again, but I'm going to change the 0 to a 1 since my X value here is 1. That's what's going to go in the parentheses. So I have 2 times 1 plus 8. 2 times 1 is 2, plus 8 is 10. So I have the point 110. Now I'm going to do 2 times 2, that's 4, plus 8. It's going to give me 12. 2 times 3 is 6, plus 8 gives me 14. And 2 times 4 plus 8, that's 8 plus 8 is 16. And here's my line. Notice we can see M and B in the graph right here. This is my B because it's next to 0. And then my M is what I'm adding each time. I'm adding plus 2, plus 2, plus 2, plus 2, so that's my M. Okay? We've got some questions underneath it. What is the initial value or the cost of the pizza with 0 toppings? That's $8. I see that in my table. 0 toppings cost $8. So, the initial value, it's just asking you about B, really. So we always see B in the table at X equals 0. And we always see it in the graph on the y-axis. That's where you'll find B. What is the rate of change? Well, we already knew that as soon as we read the word problem and saw that per, we knew $2 was our rate of change. And in the equation, our rate of change is always going to be right next to the X. Our rate of change is always going to be right before the X. Okay. Couple more. Number 4, this is another question that's having us compare graphs, tables, and equations, which are the 3 different ways you can, these are called multiple representations, because you can represent a linear relationship with a graph, a table or an equation. So that's why it's called multiple representations. So Mr. Teen asked his students to write an equation to represent the relationship shown on the graph. We're going to complete the table and figure out who did it correctly. So starting off, I need to look on my graph for x equals 0. I always know that's going to be right on my y-axis. Anytime x equals 0, that's right here on your graph. So I see that point right there, which is 0, 3, right in between 2 and 4. Then I'm going to go over to 1, that's 5. When x is 2, y is 7. And when x is 3, y is 9. So now I've got to figure out my equation, right? Remember we write equations, y equals mx plus b. And I think the b is the easiest thing to find because we just look in the table for x equals 0, and I see it right here. So that means my b has to be 3. Well, looking over here, there's only one option that has b equals 3, right? That means Ellie has to be correct. Let's double check and make sure her m is correct. I do see that every time I go up an x value, I'm adding 2. So Ellie is correct. My rate of change is 2. And lastly, we're just trying to match up these tables and these equations. So again, for each table, I'm going to need to find m and b. So starting off, right off the bat, I see each table has 0 in it. So I know since this table has 0, 3, I need to find an equation that has a 3 at the end. Well, that was pretty easy to get started. Those two have to match up. Okay, now I've got to worry about my 6's. I'm going to need to find m for each of these tables to figure out which equation goes where. So I'm going to start with this table on the top. So my x's, every time I jump in the x's, I'm adding 1. Every time I jump in the y's, I'm adding 4. So when I do m, which is change in y over change in x, I end up getting 4 over 1. That's just 4, right? So I know these two go together because this has m equals 4. Let's do m on the last table just to practice. So my x values, change to the eraser. My x values are adding 5 each time. And my y values are adding 2.5. So when I do change in y over change in x, I get 2.5 divided by 5. And if you actually do that division, you do get 0.5. So we know these two go together. Okay, I hope that does a really good job of solidifying non-proportional relationships for you.